Hello, welcome to Exergy TV. I'm your host, Melissa Dinwiddie. Under California regulations, 35% of new 2026 car models sold in California must be zero emissions, ramping up to 100% in 2035. That means 15 times more EVs on the road and 15 times 1.2 million more public chargers. While federal regulation, support, and funding will shift dramatically under the Trump administration, electric vehicles in California look to increasingly become the norm. But what about the infrastructure for EVs? Charging for single-family homeowners is fairly straightforward, requiring some electrical panel capacity and an electrician's installation. A number of car manufacturers now bundle chargers, and there are generous equipment rebates and tax credits for installations. But above all, the single-family homeowner enjoys the luxury of time. In his classic planning text, The High Cost of Free Parking, UCLA professor Donald Shoup states that the average car spends 95% of its time parked. A car in a driveway has plenty of time overnight or during the day to fill up, even with a steady drip of a standard 120-volt outlet level 1 charge. Multi-family housing is a different proposition, however. Even if parking is assigned, there's usually no electricity for spaces in existing buildings. New buildings now have some requirements for a percentage of spaces to be set aside for charging, but there's a long way to go before convenient charging access is available to all. And charging for medium and heavy vehicles is still in its infancy, with major plans for advanced clean fleets ending combustion truck sales by 2036, but major issues coming up about grid capacity. Joining us today are two CEOs of companies providing innovative solutions to EV charging. Aaron Lee of San Jose's Pando Electric and Tom McCalmont of Campbell's Paired Power. Welcome to Exergy TV.
Thank you, Melissa. It's great to be here.
So glad to have you. So why don't we start at the beginning with some lightning round problem definition and an electrical primer. So first of all, can you take us through level 1 slow charging, level 2 and low power level 2, and level 3 DC fast charging?
So that's a great question, and I like to use analogies that help the public understand because these terms are very confusing. You touched on the core issue, which is grid capacity and limitations in grid capacity. Everybody has used or has an electric dryer in their home, so they're very familiar with the load of an electric dryer. So to put that into more concrete terms with level 1, 2, and 3, level 1 is about equivalent to 1 electric dryer. Level 2 is about equivalent, depending on the charger, to 4 to 8 electric dryers. Level 3 is equivalent, again depending on the charger, to 100 to 250 electric dryers. So that level of power charges the vehicle quickly, but it's also very expensive in terms of the grid capacity limitations.
Oh, wow, that really makes it a lot more clear, the difference between those different levels. Thank you for clarifying that. That's a great analogy. So what about the categories of EV capable, ready, and installed?
So when we say EV capable, it means that the conduit, the feeder, basically the wiring to conduct the power to the parking spaces are ready. But when we see actually we have the EV charger, so that means when the car came here, he can already readily available for him to pull energy into his car. And one more thing I did want to add a few comments on the level 1, level 2, and the level 3 is besides the fantastic analogy to the dryer, is I want to compare that to the total charging hours. Say for a typical level 1 EV charger to full charge your car, typically from say 10 to 15% to 80 to 90%, take you about 20 to 30 hours. This is a long duration. So that is part of the reason that the level 1 EV charging are starting to phase out and become a legacy. Right. When we're talking about level 2, the charging duration is about 4 to 6 hours. That is to say, when you park your car for half a day or for a full night, it is very easily for you to get an overnight charging to have a full charge for you to ready to use the car tomorrow. And for a level 3 charging, depends on the high power architecture of the vehicle. Typically, it takes you any time between 10 minutes to an hour to fully charge your car. So that's why for the level 3 DC charging, we also call it the fast charging.
Thank you. That is so helpful to have that so clearly explained. Thank you. All right, so lastly, let's talk about power and energy, kilowatts and kilowatt hours.
The public is massively confused about these two terms.
Yes, we are.
Yeah. Power is how much you push instantaneously. Energy is how much you take over time. And both of those are important in EV charging. Depends on the scenario of what you're trying to accomplish. Aaron touched on this a little bit. If I have plenty of time, I'm charging at home or I'm charging at work and I'm working all day, I just need whatever I need in terms of energy over that time. I don't need a lot of power because the charger can run at a fairly low power level to deliver that energy. But if I'm on the highway and I stop at a coffee shop, I want to fill up quickly. It's more like a gas station. I want to be out of there in 10 minutes. So I want all of that energy to come at high power so I get it quickly. Make sense?
That does make sense. Yeah, thank you for clarifying that. So is there anything either of you would like to add about the California EV charging landscape, like the limitations of grid power and the challenges of delivering much more energy?
This is a great question.
Yeah.
I want echoing to first two things you mentioned at the very beginning. Say 95% of the time you mentioned, the Don mentioned from UCLA, that the car is parked. So there's abundant time for us to charge the EV because they're just parked there. So as Tom mentioned, like those give you plenty of room to lower your charging power. And on the other end, we're talking about a crisis regarding the grid. So this crisis is also about the power. The grid is sized for real-time load. That means at any given point, the supply and the demand need to meet each other. So this is actually, I would call it very ironic, is that the car has plenty time to charge, but right now we have a bandwidth, we have a power issue. This is because the infrastructure is not widespread enough so that we can enjoy those relatively low power charging, which is more grid friendly. And this is something that Pando is working on.
I love that. So let's bring this down to sort of real world situation. How do you see things playing out with the new Trump administration?
Yeah, there's a lot of concern in the public right now. Obviously, Trump is antagonistic to clean energy, but I don't really worry about it. And the reason I don't is that EVs are such a great experience. If you drive one, you fall in love with it. It's fast, it's clean, it accelerates well, it has a comfortable experience. It has very low maintenance costs, it has very low fueling costs. And so when you're in that mode, you're never going to go back to a gas car. And so the market keeps growing because as people drive them, they say, oh, why would I go back? So I really don't think, maybe it causes a hiccup, but I don't think it's going to stop the market.
I hope you're right. I think you probably are. So I want to ask you each individually some questions, but before we go into that, can you share, and let's actually, I want to hear from you individually, Aaron and Tom, what are the business problems that each of you are solving? So Aaron, what's the business problem that you're solving?
Totally. So we see it on two ends. Number one is from the state level or even nationwide. Problem is that we see there are more and more EV. People talking about there are more electric vehicles, but the elephant in the room is that there's not enough infrastructure to hold those EVs. Yeah. You think about that, typically for a level 2 charging, you need to charge your car twice or 3 times a week, depends on how frequent you drive. And on the other hand, the charging duration will take you about, say, 4 to 6 hours. So this is something that you cannot ignore. This is not like pump up gasoline into your gasoline vehicle. So to make that happen, the infrastructure need to be ready, starting from the EV charging to the grid capability and all the way to the smart grid, which we call it the demand and the supply balance. And for some people develop the clean energy, solar, wind, and how to store that, and how to make the check balance so that all the cars have convenient EV charging. To us, this is a nationwide problem for the mass adoption of EV. This is on the first end. On the second end is Pando realized that it is very interesting that the majority of the problem for EV charging comes to home charging. And the single-family home charging, as you mentioned in the opening, is a problem well solved. But the multi-family home charging is a disaster. We talk about that. It is about the upfront cost. It is about the power capacity. And it is also about the maintenance, the operation. Lots of chargers they put down there, they fail. So, and there are more trivial issues, such as like really tight parking space, cannot fit into all those like beautiful, fantastic, full-fledged EV charger. So what to do with that? So putting that all realistic problems to the mindset of the property owner, the property manager, Pando trying to provide a turnkey solution for them so that they will have that EV charging available to their tenants. Just an analogy to that is, if there's one day right now you came to an apartment and say, hey, I want to live in here, but you don't have Wi-Fi, then the tenants will leave. They cannot bear a housing without a Wi-Fi. Then maybe after a year, people who drive electric vehicle, when he gets into a building, try to rent an apartment or live in a condo there, realize that there's no EV charging available, then they will just leave. So the lower level for us is to solve the problem for those properties so that they will be ready and future-proofing their properties.
That's great. Thank you. And what about you, Tom? What's the problem you're solving?
I would add to what Aaron said. I think the two of us are solving the same problem, which is the limitation in grid capacity that you talked about, but for slightly different markets. Aaron talked about multifamily housing where that's an issue. It's also an issue in all kinds of situations where you have fleets of vehicles. You know, just to take an example, in cities around the Bay Area, currently they have a fleet of vehicles. Maybe they're inspection vehicles or service vehicles. Maybe there are 50 of those parked in a parking lot that has a gas tank in the back of the lot to fuel those vehicles. They want to electrify those vehicles, but they don't have the grid capacity at that lot to be able to do that with just depending on grid power alone. And so the problem we solve is we do that with a microgrid. We add solar to that site. We may add battery storage to that site. We manage the load of the chargers because, again, it's not an issue of power. Those fleet vehicles may charge all night. They have plenty of time to get the energy they need. They don't need high levels of power, but they do have to be managed so that across all of those, say if there's 50 or 100 vehicles, they can all get that charge overnight. That's the business problem we solve.
Brilliant. I love it. All right, so Aaron, I know that Pando Electric recently completed a project for the Woodland Creek HOA in East Palo Alto. 3 buildings, 90 units. First off, how is charging an EV more like charging a cell phone than getting gas?
Good question. So charging an EV, as we just mentioned earlier, it takes more frequency than putting gas in the gasoline vehicle, and it takes a longer time. But it is beyond that. From a perspective of EV driver, this is the kind of reassurance. Like when I joking, like me and my wife, when the battery of my EV runs to 20%, I will still stay very calm, comfortable. But when the battery drives to 35% to 40%, my wife will start okay, we need to find a charger. It is running out of battery. So we realize that it is more on top of those refueling the car. It is also about that range anxiety.
Yeah.
So a good metaphor we got with the smartphone is when you wake up in the morning, if you see your iPhone fully charged, what is that feeling? You understand, okay, I can always go to the office, go to the coffee shop to charge my phone, but the moment when I wake up in the morning, see it fully charged, this is the experience that they come with a premium.
Mm-hmm.
You're so right.
Right.
So tell us about your outlet-based approach and how you manage the system and manage costs. How do you daisy chain multiple outlets on a circuit?
Totally. So follow up on the last point is we see for multi-families, they need to provide the available EV charging to the tenants. And for tenants, they believe that the home charging gives them a premium of the reassurance. Mm-hmm. So starting with that, then we start to think about what is the biggest hurdle? what is the biggest problem to solve? We come like to the customer side, they don't need to understand all the technology, all the patents, all the amazing work regarding the product design of Pando. They only care about three things. Is it available? Is it cost effective? Is it smart and easy to use? So to make that few things happen and to focus on the particular use case, we come with the solution of the outlet-based EV charging for multifamily, or in other words, we call it the BYOD, BYOC, bring your own cord. And to make that happen, we see that there are a few advantages. Number one is without the charging cable and the charging gun, it makes it very easy to fit into the tightest parking space. We have customers in Manhattan. We have customers, it's very hard to park into their car that the pillar of the wall may just scratch the side of the car. But you know what? A Pando outlet can fit into there. And on top of that, we have the hardware that is so easy to install and that is daisy-chained. So that means multiple devices are shared the same circuit breaker and are shared the same conduit and the feeder. So that it lower the material cost or lower the labor cost and then make it really cost effective to spread out. And we do believe that there's one thing different from other EV charging companies is that we call it the bring your own cord model. That is because for the majority of EVs on the road, there is the best EV charger in the world for that particular EV. Guess what? It's the mobile cable in the trunk. So this is something people already started utilizing in single family. They pull that cord and they put it in the dryer machine, the NEMA 1450.
Right.
And they use that for charging. We think this could be the best solution to make it easy to use, low cost, zero maintenance, and flexible into multifamily. And we think we're just doing the right thing to bring that to make it available to those EV drivers and the properties.
That's really cool. And as a townhouse homeowner myself, I'm super interested in that. Tom, I want to turn to you for a moment. Paired Power evolved from your solar firm, McCalmont Engineering.
That's right.
Which designs large capacity projects. What was it like working from the power side to developing originally DC and now AC-based charging solutions?
So we started actually with DC-based power. We actually invented and pioneered a system that would take solar and directly charge the electric vehicle, directly from DC to DC, no grid. But over time we realized that this microgrid approach is actually more powerful because there are many times when storage is helpful, like you want to time shift the energy. Maybe you get it in the daytime, but you need it at night, and the battery allows you to do that. And that also, we shifted to AC charging because it's more compatible with all the vehicles that are in the market. DC's still has different standards, where AC has a single standard that works across all vehicles. So that's what we've done, and it led us into the world of microgrids, which we're really a pioneer in. It's a great solution for the problem.
Amazing. And what is tell me if I'm pronouncing this correctly, a bifacial solar panel?
So we use bifacial solar panels. One of the things you want to assure in a system like ours is that you don't have any moving parts, because moving parts are prone to failure. There are moving part systems in solar, but we didn't want to have that. What bifacial panels do, they're partially transparent, and they capture reflected light that bounces off the ground as well as light that hits from the top. So they capture light on both faces, and they get a higher energy yield, very equivalent to those systems that use motors, but we don't require the motors. So it's a great innovation.
Wow, that sounds amazing. And what kind of batteries, like chemistry batteries, are you using, and what's their capacity like?
Yeah, we use lithium iron phosphate. People are sort of confused about lithium. They've heard about fires with lithium. And the chemistries that have reactive agents in them, like manganese and cobalt, are very fire prone. Lithium iron phosphate, iron and phosphate are not flammable materials. They are not fire prone. And so they're much safer batteries. And so that's what we use.
Okay, cool. And you can operate either off-grid or connected to the grid? And how does that work in practice?
Yeah, so in some microgrid situations, like the one I described for a fleet of inspection vehicles, they have some grid capacity, and so it's helpful to combine that with solar and storage. But there are other examples where maybe that capacity isn't present. Think about a park or a beach or some remote location where you still want to have EV charging, but you don't have any grid power, we can put our system in, run it completely off grid. It's still a microgrid, still has solar. The sun comes up every day, generates energy, gets stored in the battery, is available to charge vehicles at that site.
Amazing. And how much electricity does a paired tree setup produce in a day?
So Pear Tree is our smaller system. We deliver anywhere from 75 to 150 miles of range per day with that system. So it's plenty for charging vehicles. The average commuter in the United States, 93% of people in the United States commute less than 35 miles per day. So it's plenty of range for that scenario.
That is so cool. And what's the difference between a paired tree product and paired fleet?
Yeah, so Pear Tree is the small pop-up canopy. We can erect that in a single day. It has 2 charging stations, very easy to deploy at all kinds of locations. Pear Fleet scales that up to a much bigger system for fleet charging. So it would have a traditional solar array, still have batteries, still have chargers, operates on the same principle, but is a much larger system.
Got it. Now, your website describes an installation of your paired tree chargers at Santa Clara University's facilities yard. Yes. Can you go into what they were looking for and the solution that you provided?
It was a great, they were a great customer and a great scenario. Santa Clara University is very forward thinking on sustainability. They have objectives to try to achieve net zero utilization. And their facility yard makes use of a lot of these, they're essentially golf carts, but they're used for the facilities crews to interact on the campus. We put in 2 pear trees that are able to charge 12 of those. So, so a small fleet of those little campus vehicles.
That is so amazing.
Yeah.
All right, back to you, Aaron. Tell me about the Pando Connect Us platform, is that what it's called?
Yep.
And your adaptive load management system.
Yeah, so this is coming to the particular use case and the technology we developed within Pando. We see that for EV charging, especially for multifamily, there are 2 main issues. Number one, we just touched that, is about the cable. That's where we have the bring your own cord. But the second issue is regarding connectivity. So more than half of the failures of EV charging comes with the connectivity could be coming from your phone try to connect to the server on the cloud to get authorized. And then the server will connect to the charger to authorize the charger to start the charging. It comes from the connectivity between the charger and your car. They communicate with each other. So we realize this is one of the major problems. The second major problem is, we mentioned earlier, is about the capacity issue. So take Woodland Creek as an example. The building is 20-year-old, and Pando not only deployed the 92 devices for the building, but also does not require an upgrade of the capacity, and all those 92 devices are high power level to 10 kilowatt. So to make that happen, we need a technology to enable the adaptive load sharing. So that means cars share the load dynamically. And break down one layer into the engineer side, we did 3 things regarding the Connect US or Connect Us. The first thing is we do the tap and charge. So that is the part we realize for most, maybe over 70% of the parking spaces, there's no Wi-Fi or cellular signal, not only to the charger, but also to the EV driver. So in our technology, user can tap his smartphone with the Pando app to the charger to enable the charging session, even if there's no connectivity at all. The second part is that all the charger within the same building, just through our Connect US, they can be talk to each other and do the adaptive load sharing. So that is a shield layer, say that if the server, if the cloud, if the Comcast or the Wi-Fi failed temporarily, they still function. And only by building that 2 blocks through the hardware software integration, we can achieve the third thing, which is the adaptive load sharing, which is an algorithm. It is based on the actual charging speed, the actual user behavior, so that given the capacity limit, we can maximize the usage and without spending the money to upgrade the transformer or the panel to satisfy the EV charging the overnight for as many tenants or residents in the building as possible.
Amazing. So another last question for you. Your property management dashboard looks to be set up for demand response integration, energy trading, and virtual power plants, VPPs. What level of system would benefit from this?
So this is a great question. So when we set up the company, we are thinking EV charging is the first step. We believe that the EV is such an amazing thing. Besides the user experience, the battery itself can be a great extension of the grid. So we set that vision and put into every day-to-day action and every line of the code of our software. And to make that happening, what we see that this is a system, it will satisfy different layer of customers and needs. For example, the EV driver, the property, and the grid and the energy provider. And on that end, we think that by connecting all the EVs with the high power Pando charging outlet into the grid, they can participate and contribute in terms, for example, I'll give very pertinent example is, say if there's a mountain fair again in Los Angeles, and it's a tragedy. But when that happens, a lot of the power line is being burned out. A lot of supply are being in short. So by holistically demand all those EVs to start charging or stop charging, we can make a big amount of effort, say in the scale of gigawatts, to balance the demand and the supply side for the whole city for the utility. And this is what we think demand response and the virtual power plant will play a major role with the participation of more and more electric vehicle.
That's great. I love that expansive thinking. Thank you. And Tom, question for you. What markets are you going to be looking to serve in the future?
Yeah, so we're focused at fleets, which encompasses both commercial charging, for example, workplace charging, as well as fleets that charge at night. And also government is a big one for us. There's a lot of interest. We've sold a lot of systems to cities throughout California and some on the East Coast as well as you know, like water companies, energy companies that have a need for electric vehicles. So yeah, we see all those markets as good for us.
Great, wonderful. Well, I would like to thank you both for coming on Exergy TV and talking about your EV charging solutions. We wish you so much success in your efforts to aid in the enormous challenge of scaling the electrification of the transportation sector. This is Melissa Dinwiddie for Exergy TV. See you next time.